Hello students, welcome back. In this video we are going to implement logical XOR gate using the concept of neural network. So basically before actually starting the implementation, let us understand what is the output of any logical XOR gate. So for the XOR gate, if we can see over here, whenever both the inputs are 0 or both the input is 1, then the output will be 0. Otherwise the output will be 1. Okay, this is what is the final output for your logical XOR gate. Now to make an XOR gate, we require three different types of gates. That is first one NOT gate, second one OR gate, and the third one is AND gate. So in this entire program also we will first try to implement these three gates, and then later on we will combine them and we will make our XOR gate. So now let us start. So one more thing along with this XOR gate, since we need to implement this XOR gate in the neural network using the concept of neural network, so we need to first of all understand what is the basic structure of any neural network perceptron. So here we can see this is the basic structure where we can see there are some inputs are there. We have some way value that is associated with each and every input. Then we have one bias ka thing which is again getting added to the summation of these input along with the way ka thing. So the same concept we are going to try to implement in our practical also. So let's begin. So let us start with the program. So to implement the program, we require to first of all implement this library, which is our numpy. After that, we are implementing two functions. The first function is your unit step and the second function is your perceptron model. Unit step function is accepting one parameter, that is v. Now it is checking the value of v. If the value of v is greater than 0 or equal to 0, it will return the answer as 1. Otherwise, it will return the answer as the 0. In the second function, that is perceptron model, it is accepting three parameters, which is your x, w and b. X is nothing but your input, w is your way ka value, and b is the bias value. We are basically moving ahead inside the function. We are just creating the value of v, which can be generated using the dot matrix, applying dot matrix between two inputs, that is w and x. So w and x will get multiplied. Whatever is the answer we are getting, we will just add bias ka value into it, and that entire expression will provide us with the value of v. Then we are providing this v as the input to our function, which is unit step, which we had created earlier. And then whatever is the result of this unit step, that result will get stored in a variable y, and we will return y as the output of this function. So let's just run this and see what is the output. So here in this case we will not get any output. The reason is that because we don't have any printing statement, we are just creating our functions. So this is the first part. Let us move to the another part. As I told you earlier, to implement our XOR gate, we require implementing three different gates, that is OR, AND and NOT. So we are starting the implementation of our first gate, which is the OR gate. Now for implementing the OR gate, here we need to take way ka value as 1 for way 1 and way 2, that is w2, as 1. Since we are having two input in our OR gate, we have two inputs, so we are providing two way ka value. Okay, that is 1 and 1, and the value of b, that is bias, is minus of 0.5 here. So now we are just implementing our logical OR gate. So this is the function where we are supplying the input as x is the parameter which is accepted by this OR gate. Then what is my w? My w is nothing but 1 and 1. w1 is 1, w2 is 1. So basically entirely my w is nothing but it is an array whose value is 1 and 1. My b ka value is minus of 0.5. Now what I am doing, I am just passing these three things. What three things? The first one is the input, which is x. Second one is my w ka value, which is 1 and 1. And my b ka value, which is my bias, which is minus of 0.5. Passing these three things to my perceptron model. So you can see this is again the function which I had created earlier. I am supplying these three inputs, which is x is nothing but my input, whose logical OR I need to find out. So x can be your 0, 1. 0 1, it can be 1 1, it can be 0 0, it can be 1 0. So these are the 4 possibilities of my x which I am providing. W will remain same for all the 4 tests. W will remain 1 and 1 only. Here we had specified W. And similarly, bias ka value, that is B, will also remain same, that is minus of 0.5. So this perceptron model will take these 3 input. It will take these three input, and it will call that function, that is perceptron model. So here we had created that perceptron model. Here I had told you that in this model we are basically applying dot matrix. So dot matrix में क्या होता है कि जितने भी हमारे x होते हैं, that will get multiplied, whatever is your x, whatever is your x, that will get multiplied with w का value. ठीक है. So suppose in this case we are having 2x, that is x1 and x2. So first time x1 will get multiplied by w1 plus x2 will get multiplied by w2. Okay, and then whatever is the answer of this dot matrix, that will उसमें पूरा हमारा bias का value will get added, and then we will get the value of t. So this is how this perceptron model is working, this function is working. So in our logical OR, as I told you, we are just supplying this input x, w and r, and we are just calling our perceptron model. So these are the 3 functions. So now let us just run this function as well and see. In case if there is any error in implementing the function, it will show, otherwise it will not show any output because we don't have any print statement here also. Now we need to test whether the gates, this logic gate is working properly or not. So we are providing 4 test cases. In our OR gate, we can provide 4 possibilities of inputs are there. As I told you earlier, 0 1, 1 0, 1 1 and 0 0. So each and every input I am assigning those input in a variable named as test. So my test 1, the input is 0 1, test 2, the input is 1 1, test 3 0 0, and test 4 is 1 0. Now below that I am just using print statement, and here inside this print statement I am just calling my OR function which I had created just now. Here you can see I am just calling this OR function. This OR function requires an input which will be my x. So here I am giving the input also, which is test 1. So in test 1 my input is 0 1. So for the first time the x will be 0 1. Okay, so x will be 0 1. So like this way I am just providing the second input, again calling the same function OR function only, and I am providing my test 2 as the input. Now here we can see my test 2 is nothing but 1 1. Similarly in the third case it will be 0 0, and in the fourth case it will be 0 1. As we run this module, we will be able to see all the 4 cases are getting, all the 4 tests are getting tested for the OR gate, and we are getting the output over here. So for 0 1 in the OR case the output is 1, for 1 1 it is 1, for 0 0 it is 0, and for 1 0 it is 1. So in this way we had just calculated, we had just tried to implement our OR gate using neural network ka concept. In the same manner we need to find it out, we need to implement the AND gate as well. So now here let us start with the AND gate. Now for AND gate most of the thing will remain same. Most of the thing will remain same, which means that our this unit function will remain same. Perceptron model will remain same. Okay, there is no need to make any changes in this function. We just need to re-implement our AND logic gate. So here to implement our AND ka thing, again we need to take W1 and W2 ka value, which in this case is again 1 and 1 only. There is a change in the bias ka value, that is B ka value is this time for implementing AND gate it is minus of 1.5. Okay, now again similar to our OR gate we are implementing AND gate also. Again it is taking the input, that is x. Now what is W? W still is 1 and 1 because our way ka value is 1 and 1. Only there is a change in B ka value, that is B of AND, that is bias of AND is minus of 1.5. So this is our bias ka value. Again we are calling the same perceptron model with the same parameters as x, w and b of AND this time. Similarly to our OR gate we have 4 test cases here. 1 2 3. We are specifying 4 inputs 0 0 0 1 1 0 and 1 1. and here we are just calling that AND function with all the 4 test cases. Yes, so now let us just run and see whether we are getting correct input or not for this one. Yeah, so as we run this AND wala module, we won't get any output as there is no print statement available over here. For this testing wala part, in this testing cell we got the output, that is this. Here you can see AND of 0 1 is 0, AND of 1 and 1 is 1, remaining AND of 0 0 1 0, it is 0. So here we had just implemented AND ka logic gate. Now the third gate which we need to implement is NOT gate. So for NOT gate, as all of you know, we have only one input. We can provide only one input, and there is no required of two way ka value. Here we will take only one way ka value, which is W, and the value is minus of 1. Similarly, bias ka value in the case of NOT gate is 0.5. We are just designing the function that is not of, this is the name of my function, which is not of logic function. Here again this function is taking an input which is my x, which will be 0 and 1 in this case. Then W is my way, which is minus 1. B is nothing but the bias ka value. Again I am calling the perceptron model with these 3 parameters. My test cases, here I had used 4 test cases, but if you want you can go with the 2 test cases as well, because in our NOT gate we can test only 0 and 1, so there is no harm testing it 4 times also, or you can go it with 2 test cases as well, one with 0 and the second one is with 1. Okay, so here again I had taken 4 test cases. Again 2 of them are same. See, 1 and 1 is same and 0 0 is same. I'm just calling these 4 functions again with 4 test cases. When I run this part, when I run this function, so as I will not get any output for the function, but when I run this test cases wala block, I'll get some output. So here you can see not of 1 is 0, not of 1 is 0, not of 0 is 1, not of 0 is 1. So basically it is giving the same result. Okay, now since we had implemented all the 3 gates which we require to prepare our XOR gate, that is हमने AND gate को implement कर दिया, हमने OR gate को implement कर दिया, और हमने हमारे NOT gate को भी implement कर दिया. अब हम लोग हमारे XOR gate को बना सकते हैं. So to make that XOR gate, we are again making a function named as XOR logic function. Again it is taking an input, that is again that 4 possibilities 0 0 1 0 1 1 1 0 1. अब यहाँ पे हम लोग क्या कर रहे हैं, इन दिस XOR gate हम हमारे AND gate को कॉल कर रहे हैं. जो हमने AND गेट ऊपर बनाया है उस फंक्शन को कॉल कर रहे हैं. उस फंक्शन से जो उस फंक्शन में हम लोग इनपुट भी दे रहे हैं, वही 4 पॉसिबिलिटीज जो हमारी है, दैट 4 पॉसिबिलिटीज ओनली वी आर प्रोवाइडिंग एज एन इनपुट. अब ये फंक्शन का जो भी आउटपुट आता है वो हम लोग y1 में स्टोर करते हैं. सेकेंड टाइम वी आर कॉलिंग आवर और फंक्शन और गेट में वापस से वो 4 पॉसिबिलिटीज दे रहे हैं, और इस बार जो और का आउटपुट आएगा वो हम लोग y2 में स्टोर कर रहे हैं. तो ये तो हमारा एंड और OR हो गया. हमने ऊपर डायग्राम देखा था, डायग्राम में देखो वी आर अप्लाइंग नॉट ऑन आवर एंड गेट. तो सी द डायग्राम, लेट अस जस्ट सी द डायग्राम वंस अगेन. तो यहाँ पे आप डायग्राम देखोगे तो जो पहला ये डायग्राम में जो फर्स्ट पार्ट यहाँ पे हमारे पास है, दैट इज यहाँ पे देख, अगर आपको दिख रहा है जो ए वाला पार्ट विच इज गोइंग एज देन इनपुट, यहाँ पे एंड गेट में उसके आगे एक छोटा सर्कल है विच मीन्स दैट उसका नॉट हो रहा है, नॉट ऑफ दैट एंड गेट. सो द सेम थिंग वी आर ट्राइंग टू इम्प्लीमेंट हियर ऑल्सो. सो नीचे अगर आप आओगे तो यहाँ पे सी वी आर अप्लाइंग नॉट gate. On what we are applying? We are applying NOT gate on our y1. Now what is your y1? Your y1 is your AND gate. So AND gate के ऊपर हम लोग क्या कर रहे हैं, हम लोग हमारे NOT function को अप्लाई करें. तो बेसिकली ये हो गया एक NAND gate. This is my your NAND gate, AND gate and OR gate. तो ये तीनों गेट को मिला के हम लोग हमारे XOR गेट को बना सकते हैं. So these are those 3 functions of all the 3 gates. Now we are making one final variable, that is final underscore x. So what is your final x? Which is nothing but your y2 and y3. What is your y2? That is your OR gate, और y3 is your NAND gate. तो यहाँ पे आके देख लो डायग्राम में वापस से एक बार, जो हमारा फाइनल लास्ट का जो AND गेट है, इस AND गेट में NAND का और OR ka input is going. So again coming back here, so now this is our final input, that is y2 का जो भी result है and y3 जो भी result है, these are our final input as x. Now we will provide this input to our final gate, that is AND gate पे हमें उसको apply करना है, and whatever answer come, that answer will get stored in final output variable, and we are returning final output का thing. So this is what is the function of my XOR gate. So I'll just run this. Again there are no errors are there. So now let us move to the last part. So here I am just serving the inputs for my XOR gate, that is for my gates, that is 0 0 1 0 1 1 and this. So now these inputs are going into my XOR function. These inputs are going into my XOR function, and at the end the result is getting calculated. So this is the final result. We'll run it, we'll see. This is the final result where you can see only for input 0 0 and 1 1 the result is 0, otherwise the result is 1. So this is what we had seen in the table as well, कि only for 0 0 and 1 1 the result is 0, otherwise the result is 1. So that is what is your implementing of XOR gate using neural network concepts. So that's it in this video. If you like the video, hit a like, share it amongst your friends, and do subscribe the channel. Thank you, students.